Hello.
Hello, guys.
Hi, Angelo.
Hello.
Hi.
Hello.
Hi guys.
Good morning, good afternoon.
Yeah, would you like to lead the call or do you want me to start?
Yeah, feel free to start.
So I think one of the topics that we would like wanted to discuss is like a long standard due for the RFC review for the core AP getaway proposal for the Hyperledger Fabric. So I asked Bernardo to join the call and make the presentation to outline and explain the motivation and the proposal. So we will be able, first of all, we all will be aware of the proposal. We'll be able to ask the questions and make a final decision because there is going to be going a long. There was a long conversation on the WC. I think people started to approve it. So before doing the final call, I believe that it's beneficial to leverage the community call to give it a review. Also, given we have a recording, so we can also record it and the opportunity for others to ask the questions. So, Bernardo, would you like to get started with the presentation?
Yeah, definitely. Hi, thank you, first of all. So I will just share my screen. Let me just check. I think you guys now are seeing the right thing.
Yes.
Okay, nice. Let me just sort of these. Okay, so first of all, I will try to be very brief, sort of, because this presentation was done quite a while, and the current status of the RFC has moved towards a bit of a different perspective. But yeah, I will try to be kind of light. So yeah, the main takeaway for this is really a new way to communicate to Hyperledger Fabric, enabling resource-constrained devices to properly connect and do every kind of task, evaluate, endorse transaction, every type of transaction with Fabric. We have been doing this on a few projects here. Do some necessity really on some IoTs where we have on two different use cases. One is the warehouse where we evaluate humidity, temperature, and all sort of that stuff in open threads network. And we were trying to communicate with a few events and records that we have in a network based on Fabric. And when we try to communicate directly using the SDK, we verify that the the use cases was proper, but the hardware wouldn't handle using the gateway or using the SDK. And yeah, we were trying, maybe this is a miss that Fabric doesn't quite handle well. Then we try to use the protos, try to go really on the basis of the things using HTTP2. And yeah, still the hardware is so constrained that we are trying to do as minimal use it and minimal libraries and minimal usage on that. So yeah, going forward, so this is the agenda of the presentations, the core problem, motivation. We were trying on, or I'm trying to use a very principle that is try not to reinvent the wheel, try to use standards, trying to use something that Fabric and the maintainers are already used to it. And yeah, then this the proposed architecture, the implementation, and yeah, a deep look on what this can be mean or not. So moving forwards, yeah, I just started, and it's really a problem on the resource constrained devices that cannot handle the current ways that Fabric has to for clients to use it. As I said, we were trying to use even the protos by itself and go underneath the HTTP2, and we couldn't even handle that. So we were trying to think, why not using co-op? It's a way to communicate, it's light, and we were trying, and the hardware by itself handle very well the scope transport layer. So we were trying to go by that way. So the motivation to me, it's real clear. gRPC currently was using way too many resources on the type of devices that we have. And just also to say another use case, we have use cases where we have callers on bovines that are far away from my location, and we are trying to also do the same thing, track and all sort of vital ways of the bovine. And we focused that it was two similar cases where we want data, we have the data, but we want to communicate it to our Fabric network, and we really cannot do it directly without any type of gateway or proxy or sort of thing. So that was one of the things that why not communicate directly. But yeah, first of all, the gRPC, that is one of the ways that Fabric has to do all sort of low-level communication. The devices cannot really handle. So another point is that they cannot really connect directly. So we need to use these gateways and these sort of middle pieces or proxies to start doing things. And this introduce a single point of failure, introduce someone can trying to listen to the calls that we are trying to do. You guys might already know all of these. So yeah, the main focus was really to try avoid all of these middleware in the middle. So yeah, those were really the main points. The target devices are like IP native constrained devices running COPE to connect directly. I'm not talking any type of ZigBee or Bluetooth or whatever. None of that. Those type of devices. This is for real particular type, but still broad. So we go to the proposed solution, COPE. Why? Is the constrained application protocol. It's really lightweight. It's focused on web transfer for constrained nodes, and it's really a standard on IoT devices. It's one of the most common uses. It's built on UDP, making it really, really light to do asynchronous communication for these devices, and it can still have this, and it is secure by default, and it can combine DTLS or other type of TLS to make it a bit more coherent and to have some acknowledge of receiving the information. So that's why we use scope, and basically this are the basis of the things that we are trying to deconstruct. We have a problem, then what do we use? Scope, where, on constrained devices, and then it comes up the core principle: reuse, do not invent. The first idea, and this is where things are a bit changed from the ongoing conversation on the RFC, we were verifying that we could maybe just reuse straight up the gRPC gateway logic and just create a COPE focus on. But this would be, and from the conversation that we have been having on the RFC, we verified that it's really not needed that much complexity. We can focus on the protobase to define with the proto-C plugin, focus on Gen co-op, and just create the necessary protos to communicate directly. What will happen is that these protos that will be available on the API v2 will be just forwarding the communication to the gRPC gateway. So it's really just an adapter, a thin adapter that we come up to enable this type of communication. It will use the exact same proto definitions that will be on the protos. So really no new ways to communicate. We still use the protos. We still use the same endpoints, nothing really new. I've come up a bit with really large scale, where would the sensors communicate directly to the peer, since the peer will handle and has to handle this communication. And this was the idea first. I then might go towards the RFC just to update a bit. We would like communicate via the co-op, and the co-op server would communicate directly with the gateway servers. However, currently what we are seeing is that this COPE server will be just a thin layer over the gRPC server that will enable all types of communication. Here on the security, it's another point that already has been evolved during the RFC. Here, first, I just present a single X509 certificate to do the authentication of the device, and then to execute all sort of transactions to be identified by the CA. However, now we have a dual certificate to do both things. Both are coming from the CA. But one will be focused on identifying first the IoT device that can execute transactions to this thin adapter, and the other one will be the one that is just ruled exactly as the same as normal certificates I've been doing on the fabric. So yeah, this I might skip since it's a bit distinct now. I just introduced a few of the endorsed flows. What would the IoT need to do to execute properly the communication. This maintains, but this, I think, during all the changes of the RFC, these still are really the main points. We just focus on the new dependence that will be the cope. This will we will need not on the core YAML, but on the buff YAML. It will be a new plugin, and we are trying really to have minimal core impact regarding really the gateway. We are not really trying to do anything new. We are just trying to add something that will enable these constrained devices to communicate properly and directly to the fabric. Just to give up a summary, since I already used 10 minutes. Yeah, we really focus on the Fabric's ACL model, no new assumptions. We are really trying to eliminate this complexity of having the middleware and not being able to communicate directly. And yeah, really to allow these constrained IoT devices to execute properly to the Fabric network. I might just showcase one thing first. I still think that you're seeing the RFC. As you can see, it has a lot of conversation, but it's really focusing. I might be over here. Let me just check. Yeah. So this was like the final answer that I had to take on a few maintainer questions. That was what would really do, and this was really the main point, that how can we easily enable clients and constrain clients to use this functionality. And yeah, the main way is really by the protos. Since the protos will flow sort of Fabric protos and then Fabric protos API v2, as I have here, some sort of flow that will describe that, and then to Fabric. Why not be in that pipeline where we enable these the necessary protos to communicate via co-op? And yeah, I come up with this ProGen Go Co-op plugin, where we would just need to add this new plugin. We would automatically generate the gateway code PBGo. It would be just alongside the gRPC. So it would be enabling in an automatic way, without any sort of manual entry or manual control, a way to move forward and create a viable way to communicate. I then showcase a few examples of the gateway proto that would be generated, right? And yeah, it just has the RIPC gateway calls and endpoints. And on the client side would be even more simpler. We would just need to do this new gateway co-op client and just trying to endorse. So this is really straight up basic things that we already do with the gRPC and the available gateway. But yeah, we would enable just a new way to communicate. I then showcase a few other things, what we would create or generate. This is mostly generated code. And yeah, we would just basically generate both client methods and path constants that would move on forwards to the Protos Go API v2. And then we would eliminate the manual maintenance on both sides. This adapter will be on the peer, as I said prior, on that image that really needs to be updated. And yeah, it's really a thin translation layer with zero network overhead that would enable direct access to the gateway servers. So this is the current status. I've been talking with PFI about these. Other maintainers have come up with a few other things, but it's mostly sort of where would be the code post. And yeah, this is a nice summary of the changes that have been made on this RFC, the dual certificate security, and this tool chain integration with the Proto-Siege and Go co-op. And yeah, I think this might be an overall look of the whole of the presentation and the whole of the RFC. So Artem, I don't know if we have any questions or anything pop up. Now
I
might
have
be a good time. Yeah, go
I have
ahead.
a couple of questions. So just to understand better. So is your proposal that the IoT device connects directly to the peer? And if yes, what about the order? So who submits transaction to orderer?
Yeah, the flow will continue. We are as straight up as already is. So we were just executing the call. Currently, we on any typical application, and correct me if I'm wrong, we just have a connection profile that we connect to a specific organization or a specific peer, and we execute calls via the gateway. This way is really the same way. We communicate directly to a peer, and the peer will do the flow of executing the transaction. The transaction will still be endorsed, and by that, if I have the proper endorsers, the order will then evaluate when and where it could be submitted, and then it could be submitted by the peer. So the flow is really the same one. This is just a connection side thing. Because the main thing that we currently have right now is that we cannot communicate directly to this peer or to this organization. We need to have this middleware or this proxy anywhere that needs to have this connection and then send off the endorse and do the submit. So the flow of the transaction will be still the same.
Can colleagues in call confirm that the new Fabric gateway, independent from this RFC, takes care on peer to submit transactions to order, just for my knowledge, because I missed the newest changes.
Artem, go ahead.
Can you explain the question? Because I'm not sure I was following.
So let's say a couple of versions ago, the client was responsible to send transaction to peer, then he got the endorsements, and then he
All right, but
transaction to
since
orderer.
then we developed a gateway service that is responsible to do the entire coordination. So basically, client still can do the coordination as you recall, to make an endorsement, collect the signatures, then sending to the ordering service, subscribing to events, waiting until the transaction will be confirmed. But since the gateway service was introduced, you can now send to the gateway service, to the gRPC server of the gateway service, a request. The gateway service will do the coordination and just reply with response once ready to the client. So as far as I understand, burnout proposal is basically to extend the gateway service. And now, instead of having the one gRPC server that used for the regular Fabric clients, also to support the IoT devices, with the co-op server. So it's kind of now is going to have two endpoints, one for the normal clients and one for the IoT.
Yeah, exactly. Just enabling IoT communication.
This is Angelo. I have a question. It's more about the security domains. So if this IoT device connects directly to a Fabric peer, the Fabric peer can do whatever he wants. It's not that there is he can do whatever he wants. So then you have to tell us what's your trust assumption. If you say that the Fabric peer is in the same trust domain of the IoT device, then I would say, okay, that's not a big deal to extend. It's really not a big deal to say there is a proxy that is also in the same trust domain and it does the job without having to modify Fabric, the internals of Fabric. Full disclosure, I was against the gateway to be embedded directly in the Fabric peer because this to me was an overload of the code base that needs to be maintained. So my problem is every time we accept a change to Fabric, someone has to maintain that code as well. So now, if you tell me then this Fabric peer is not in the same trust domain of the IoT device, then you are doomed anyway. No matter what, this peer can do whatever he wants. Can even tell the IoT device, yeah, I sent the transaction, no worries. So what are you really solving by really putting this inside Fabric?
So if I understand your question, the main thing is that we need to trust this middleware device. We need to trust whatever is happening on that the communications are going directly to the peer and being directly sent, endorsed, and then submit. And then we would just receive what. If you cannot control the middleware.
No, wait, but this is true only if you say
that
this is true only if you say that the peer is in the same trust domain of the IoT device. So that then the IoT device can believe that the peer is really doing what it's supposed to do. So why don't you apply this assumption to the middleware instead of the Fabric peer? The communicating directly with the Fabric peer doesn't give you necessarily something. You have to spell out the trust assumption. So if the peer is not in the same security domain of the client cannot assume that the peer will behave as expected. Indeed, the client in this setting, the client might have to contact multiple peers to ask the same operation. So again, if you tell us that the IoT device connects to only one peer, you are implicitly saying that this peer is trusted by the IoT device. And if this peer is trusted, I say that you can extend this assumption. You can tell directly that the middleware is the proxy is trusted. So we don't have to modify Fabric.
It can really connect to any type of peer that you put in the configuration. I think I understand your question. It's just like if you not trust the middleware, but you're in the middleware, have the connection to the peer, why would not trust the IoT device that has still a connection to a specific peer? I think the main difference is that we avoid really having these third parties, and we can execute the calls itself by the sensor or the IoT device directly to any type of peer, and the device itself can verify if the transaction has been set or not. That to me, it's really the main change.
How would the IoT device check if the transaction was sent?
It can do any type of evaluate transaction to verify if the status is still or status quo as it has been sent at prior. It
cannot really, you're right, because the
ways.
IoT device to have this guarantee, it would need to
But Angelo,
validate the chain.
I mean, that might have been a valid question if we didn't have a gateway service, but we already have a gateway service, right? So that's kind of already applied to the fact that if client to utilize the gateway service, he has to try it to trust it, right? And how is that different for the IoT device? Like why if we introduce the gateway service to assist a client to coordinate the submission of transaction, or actually the execution of transaction is different from the same thing that is introduced here for the IT devices. Like if I hear you correctly, you lean towards saying that let's put a different component, a middleware that will do the coordination instead introducing this change directly into the Fabric.
No, I don't want my point. I'm starting from the point. I'm trying to play devil's advocate. So my position is I don't want to change Fabric, and then I'm trying to understand. Do you really have a point? Does your argument convince me that we really have to change Fabric? Because changing Fabric means then the new code needs to be maintained. So it's a cost for the Fabric maintainers. I'm not a Fabric maintainer, so unfortunately I don't know if there are Fabric maintainers on the call, but this is the real question. The maintainers will decide: Are we willing to maintain this code? Yes or no? Is it bringing anything to Fabric? Yes or no? So the case that you make by saying that by saying that this is easier for the IoT device to send directly to the IoT because you remove this middleware, and this is not, to me, it's not convincing for the things that I said before about the trust assumption. So either you have a stronger argument for having it there. Otherwise, I can even have an argument. So I can play the argument that we should remove gateway from Fabric. It should not be there. So this is what I'm saying. I'm not a maintainer, so I don't have a vote. I'm just one of the architects of Fabric. So in this sense, I want you should be able to defend your proposal against the fact. So without using, so it's not the trust assumption. Your point. It's not that you are you are relaxing the trust assumption by injecting this new code in Fabric. And if this is not you see, it's a I would. It's fine. It's a good cost to pay if you tell me that you are reducing the trust assumption. Then your system is more secure, but you are not really making it.
Right, but it's still improving the ease of use for the Fabric clients who is focused on the IoT workloads.
Why? I mean, the gateway can respond in the
Because
same.
it's less moving parts.
Yeah, it's
Fair
less
enough,
moving part, and the
but there is
current
a cost to
devices,
pay. Yeah,
Angelus, just really
fair.
a small point. The current devices cannot really use the gateway as it is uh, due to the constraint of this architect. So that's why I think giving this possibility introduce new players and this really a new batch of clients just to use it and enabling. I understand the point of the security on moving swords and back and forths, but if we're using any type of middleware, we are just also introducing another point of failure. We are not enabling the client directly to communicate to the network. We are not enabling these sort of use cases to be implied and use Fabric. Those are also a few points. But I think you were going to say something.
No, it's fine. That's the maintainers will decide, and that's if this is enough to bear the cost of this new code, I would put it this way. Okay, I'll stop here. That was just my point. It's not for the trust assumption. It's not for because the security it's better or something like this. You need everything in the same security domain. Otherwise, the IoT device has to do a lot of work anyway to make sure that it's not cheated in some way.
But you get by doing this, we are enabling the check. Yes, it's complex. Yes, it might have some cost on the part of the IIT, but we are enabling to be used. And now we really don't have any way for these IoT devices to communicate directly. Just a point. But I got your point also.
All right, thank you.
Thank you, Angelo. So, are there any other questions or comments to the presentation?
I had a question about the device itself and whether it will do the certificate signing request itself, or is the key loaded in a different way along with the certificate? I know that's not really part of the core proposal, but I'm still interested.
Yeah, that was one of the latest parts that I introduced to the proposal, and I can't really even say it, but what I put on. Let me just check it. On the security part. Yeah, so these dual certificates, the two distinct pairs, one will be just really transaction authorization, and the other would be just to do the disconnection. I still think that I still don't even define if where we do this setup or this authentication of the initial setup. I think it needs to be first defined prior for the CA, but even the IoT itself can do the call to have it and then to be signed, and then just having it on its hardware. We verify a few almost as vaults that these IoTs can have and hold this sort of key, the key and the certificate of this communication part. So I think, yeah, that's it. I don't think. Can you just say again the question, or if you
Yeah,
were?
so I've worked on an IoT project before where we didn't get as far as actually submitting the transaction in the end, partly because of the resource constraints that you were talking about. But we were able to use the secure element of a certain Arduino device, and then use that key to actually do the certificate signing request with Fabric CAs. So if you want, I can look up the code and share it with you as well.
Yeah, but it will be that signing will be done by. We are currently the way that we are doing the IoT itself is doing the signing of these transactions to be sent up. So yeah, it's done on the IoT device. Yeah, the endorsement to submit part are both of them are done by the IoT,
Right.
because he also the identification.
Okay.
I then can share maybe a few things about it, how we did it, or if you are interested, just
I'm interested.
contact
If you
me.
have a link, then I'll look into it. Thanks.
Yeah.
And I'll check the RFC, of course. Uh, Okay, Ilya, so shall I continue?
Yes.
All right. So, different subjects. In our previous Fabric X maintainers call, we had a conversation about something called Fabric EVM that I'm developing together with Eyal and Ale. And Ilya asked me to do a demo on it, so I'll do that. Share my screen. All right. So just an introduction of what it's all about. We want to make Fabric EVM compatible, and that means the API of Ethereum-like networks, but also be able to execute Ethereum chain code. So this is an example of a typical Fabric 3 network or 2. So you have an application that does does the endorsements requests, and well, I've always then submitted it to the orderer myself, but apparently that can be handled automatically now. So right now on Fabric X, we actually don't have the chain code anymore. The principles are the same. You need endorsed transactions to submit. So our proposal, and this is not an RFC, by the way. We will submit an RFC, but it's really meant to be drop-in components. We have developed or are developing two different things. One of them is what we call the EVM endorser. So this is like a pair, and they can execute transactions, Ethereum transactions. And as a result, they will sign the read-write sets of that transaction, the outcome of it. And we have a gateway. So this is a JSON RPC API that speaks Ethereum on the outside. And it basically acts as the application. It acts as the coordinator to get endorsements for the EVM transaction and then submit it to the orderers, get it committed, and that whole part. So Angelo, speaking of trust assumptions here, so the endorsers, every organization can run their own endorser. You can configure it with a Fabric identity. It's just another pair, basically. And the gateway has a client identity for a particular organization. It's then up to the organization how they expose this API and if they expose it to the outside world at all. But it's possible that multiple organizations will each have their own gateway with their own access control rules. I have a demo, but if there are any questions, then I can answer them in the meantime as well. And if not, I'll just show.
Is that kind of interoperability solution between the Fabric X and the EVM-based networks?
Yeah, I see it as a kind of more of a compatibility layer, enabling Ethereum-like transactions on Fabric. So it means that anyone who, from the outside, for the developer and the user, it's just another Ethereum network, like a layer 2 or whatever. It just looks and behaves the same as Ethereum. And then for the operator, they just have to add a couple of components, make sure that you have the right endorsement policy, and you're pretty much good to go. But all the consensus and all the security, the PKI is all Fabric.
Could you
Okay,
please,
okay.
Arne, could you please comment on Fabric X/Fabric compatibility?
Yeah, well, I can say where we are now and where we want to be. Those are two different things, of course. We started it only end of last year. At the moment, we are compatible with Fabric 3, and we're working on also being compatible with Fabric X. So we need to have some different parsing methods and some tricks for things that we don't have in X that we used to have in Fabric 3. But we don't foresee any issues in porting it to be able to compatible with either. Okay, so now I'm running it, or well, in this video, I'm running it against a Fabric 2.5 network because the Block Explorer is not yet compatible with Fabric 3. So that also works. So what you can see here is a fresh Fabric samples network.
Okay, can I ask the question? Why would you need the compatibility with Fabric 3? I mean, aren't you showing the Fabric X thing? I mean, why do you need the compatibility between those versions?
So many people are using Fabric 3 or will keep using Fabric 3, and Fabric X will also be used, but sometimes for different use cases. And because the protobufs and the whole structure is so similar, we thought it would be valuable to, from the start, be able to support either. Does that make sense?
Okay, yeah, okay, thanks, got it. Thanks.
Okay. Right, so two pairs, one orderer, one channel, one namespace or chain codes. What I'm doing here is using standard Ethereum tooling to deploy a smart contract, an ERC20 smart contract with some basic funding. This is 1,000 gold that is in the supply of this contract. So the block is added here, and here you can see that it's actually converted to a Fabric transaction that is endorsed by the Fabric EVM endorsers, which just look like pairs for this. So this is a read-write set where the write is the contract address with the code, and it's the bytecode that the EVM uses. This is a block explorer. This is the Ethereum view. So this thing is actually talking to our gateway API. And it's really fancy because it can see that we created a token based on events that were created on the ledger. You can see the smart contract address here and one transaction that was the contract creation a minute ago. What else do we have? Oh yeah, another cool thing about Ethereum is wallets. And this really shows how nice it is if you have that compatibility with the API. MetaMask is a standard wallet, and I was now able to also use my wallet to hold tokens. So now using the other tool again, sorry about that. The other tool again to transfer some funds. So transferring it to my MetaMask wallet in Firefox. And this transaction is executed by the EVM, endorsed by Fabric, submitted to the orderer, and now it's back visible in the API and in the block explorer as well, with some details where you can see that 100 gold was transferred to my account. And just different views of that same thing. This is an event, so this is stored as an event in Fabric as well. And the current state of the accounts. No privacy, but that's how Ethereum works. And you can see here that also my wallet now automatically updated because it's talking to the API and it knows. So let's see if we can do a transfer as well. Well, I know the answer. So I'm sending it back to the account that actually sent it to me, or sending 5 back. So the transaction now is signed in MetaMask, then submitted to the gateway. The gateway then talks to the endorsers, and the gateway signs that transaction with its Fabric account. So we have 2 layers of security, basically, or identity, and both have their own value, of course. So yeah, you can see here as well, it's confirmed. And it's all pretty neatly integrated. And this example is 2 common things like a block explorer and MetaMask, but it means that you could connect any wallet. So if you want custodial solutions, let's say you have digital asset haven. By the way, this is the read-write sets. So you can see that the smart contract here updated the balances of the different parties involved. So this is all Fabric. If there's MVCC conflicts, it will reject. That's all unchanged. So if you have something like digital asset haven or some kind of custodial wallet, you could just plug it into your Fabric X network as well, if you're willing to do Ethereum style transactions on there. So that's what I wanted to share. Our current plan is to release it soon as a Hyperledger Lab. And we welcome feedback in the meantime, of course. And otherwise, I'll keep you posted.
The goal is so basically now I can take a smart contract written in Solidity and be able to run it with the extension that you did on top of the Fabric X and the regular endorsement model that imposed by Fabric X.
Yes.
Nice. And that was already integrated, so it's something that we can get a try and see how it works. And can it get interconnected with the EVM networks, like, or it only works for the Fabric?
Yeah, that's a very good question. You still need some kind of operability layer. We try to be compatible as much as we can, but we skip the Merkle trees and we skip balances for now, and gas metering. So we won't be 100% the same as an Ethereum network. However, most of the solutions that do interoperability between Fabric and EVM, or sorry, between EVM kind of networks, don't even need that. So you could imagine that we could use something like Chainlink, or we don't have a clear answer to it yet how we want to do that, but we know that it's going to be still very, very important. There are different ways approach it. We don't get it out of the box, but it will be one of the important parts.
So you mentioned that you don't have a gas. So basically, you kind of bootstrapping the EVM with like infinite number of amount of gas, and then you just okay, I got it.
Right now we are. Alle and I were talking about it, and his suggestion is to still meter it, but use it as a kind of DDoS prevention. Just make sure that we don't have endless transactions going on. But if you want
Okay.
to introduce actual gas metering and also people's balances, then you also suddenly need an economy or some issuance of balances or something that we want to stay away from for now.
Okay, got it.
Oh, and by the way, how we do it is we just have the EVM of Go Ethereum. So that should hopefully lower the maintenance burden as well. So we get everything from the compatibility layer. We got a lot for free already from there.
Okay, nice.
Yeah,
Very,
so
very interesting.
the ultimate idea is that any company could take any Solidity smart contract or smart contracts, and then they get all the innovation in the financial world, which happens on top of Solidity/EVM, and all the performance and security they get from Fabric. So that it is possible to connect these two worlds.
Yeah, exactly.
Nice.
Thanks.
Okay, very cool, guys.
So Arne, I hope that in the next 2-3 weeks there will be a written description of what you did and plan to do, yes, which will be transferred in the lab, and which also eventually we want to move also to the main project, mainstream. To be discussed how, under which repository, and so on, but that's kind of the long-term vision.
Yeah, great. Yeah. Looking forward to actually releasing it and hopefully getting some people interested to contribute.
Exactly.
Okay, thanks.
Any other questions, comments?
Not from my side.
Okay, then I think we are done today with our agenda. Thanks, everyone, and see
Thanks,
you.
everyone.
Bye.
Thanks.
Yeah.
Have a good day.
Thank you.
Bye.
Bye, guys.